NEC 312.8 addresses the use of enclosures, including panelboards, as junction boxes or raceways for conductors that feed through or tap off. It stipulates that such use is permissible only if adequate space is provided for this purpose. The core of the requirement lies in ensuring that conductors do not overcrowd the wiring space within the enclosure. Specifically, the rule mandates that the conductor should not fill the wiring space at any cross-section to more than 40% of the cross-sectional area of the space. Furthermore, when considering conductors along with splices and taps, they collectively should not fill the wiring space at any cross-section to more than 75% of the cross-sectional area of that space. To comply with NEC 312.8, detailed calculation of the available wiring space within the enclosure or panel board is necessary. This calculation takes into account several factors, including the dimensions of the enclosure, the presence of existing components such as switches and overcurrent devices, and the allowable fill percentages specified in the code. The process involves several steps. Firstly, you need to determine the total cross-sectional area of the enclosure or panel board. This is typically achieved by measuring the width and height of the enclosure and multiplying these values to obtain the area. This total cross-sectional area represents the maximum potential space available for wiring. Secondly, calculate the maximum wiring space allowance. According to NEC 312.8, the maximum allowable fill is 40% for conductors alone and 75% for conductors, splices, and taps combined. Therefore, you multiply the total cross-sectional area by these percentages to determine the maximum wiring space allowance for each scenario. Thirdly, deduct the space occupied by existing components. Enclosures often contain switches, overcurrent devices, and other components that take up space within the enclosure. To accurately determine the available wiring space, you must measure the space occupied by these components and subtract it from the maximum wiring space allowance calculated in the previous step. This subtraction provides the actual available wiring space for new conductors. The result of these calculations is the available wiring space for you to use for new conductors. It is crucial to ensure that the total cross-sectional area of all conductors, splices, and taps that will be installed within the enclosure does not exceed this available wiring space. Failure to comply with this requirement can lead to overcrowding, overheating, and potential safety hazards. Consider an example calculation. Suppose you have an enclosure that measures 12 inches in width and 18 inches in height. To determine the total cross-sectional area, you multiply these dimensions together, resulting in an area of 216 square inches. Next, you calculate the maximum wiring space allowance. For conductors alone, this would be 40% of the total cross-sectional area, which is 0.40 multiplied by 216 square inches, equaling 86.4 square inches. For conductors, splices, and taps combined, the maximum allowance is 75%, or 0.75 multiplied by 216 square inches, equaling 162 square inches. Now, assume that the enclosure contains existing switches and overcurrent devices that occupy a total of 40 square inches of space. To determine the available wiring space for new conductors, you deduct this value from the maximum wiring space allowance. For conductors alone, the available wiring space would be 86.4 square inches minus 40 square inches, resulting in 46.4 square inches. For conductors, splices, and taps combined, the available wiring space would be 162 square inches minus 40 square inches, resulting in 122 square inches. Therefore, in this example, you would need to ensure that the total cross-sectional area of all new conductors being added to the enclosure does not exceed 46.4 square inches if considering conductors alone, or 122 square inches if considering conductors, splices, and taps combined. When calculating the cross-sectional area of conductors, you must refer to the appropriate tables in the National Electrical Code, NEC, such as those found in Chapter 9, which provide the dimensions and areas of various conductor types and sizes. These tables allow you to accurately determine the space occupied by each conductor. Keep in mind that the NEC specifies different fill percentages for different types of enclosures and wiring methods. While NEC 312.8 provides specific requirements for enclosures used as junction boxes or raceways, other sections of the code may apply to other types of enclosures or wiring scenarios. It is essential to consult the relevant sections of the NEC to ensure compliance with all applicable requirements. It is also important to note that the term adequate space used in NEC 312.8 is somewhat subjective and open to interpretation by the authority having jurisdiction (OJ). The AHJ is the local electrical inspector or other official responsible for enforcing the electrical code. Therefore, it is advisable to consult with the AHJ before undertaking any work that involves using enclosures as junction boxes or raceways to ensure that your plans meet their requirements and interpretation of the code. The intent of NEC 312.8 is to prevent overcrowding of conductors within enclosures, which can lead to several potential problems. Overcrowded conductors can generate excessive heat due to the limited ability to dissipate thermal energy. This heat can damage the insulation of the conductors, leading to short circuits, ground faults, and even fires. Additionally, overcrowded enclosures make it difficult to safely work on the electrical system. It can be challenging to identify and access individual conductors for testing, maintenance, or repairs. This can increase the risk of electrical shock or other injuries. Furthermore, overcrowded enclosures can hinder the proper functioning of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to trip or blow when the current exceeds a certain level, protecting the electrical system from damage. However, if the enclosure is overcrowded, the heat generated by the conductors can affect the performance of these devices, causing them to trip prematurely or fail to trip when needed. This can compromise the safety of the electrical system. In addition to the fill percentages specified in NEC 312.8, there are other factors to consider when determining the appropriate size of an enclosure. These factors include the number and size of conductors, the number and size of splices and taps, the bending radius of the conductors, and the need for future expansion. It is generally advisable to choose an enclosure that is larger than the minimum required size to allow for future growth and to provide adequate space for working on the electrical system. Proper planning and calculation are essential for complying with NEC 312.8 and ensuring the safe and reliable operation of electrical systems. By carefully considering the dimensions of the enclosure, the presence of existing components, and the allowable fill percentages, you can determine the appropriate amount of wiring space and avoid overcrowding. This will help to prevent overheating, electrical shock, and other hazards. When working on electrical systems, it is always important to follow safe work practices and to consult with a qualified electrician if you have any questions or concerns. Electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. Also, remember that the NEC is a complex and constantly evolving document. It is important to stay up to date on the latest changes and revisions to the code to ensure that your work complies with the current requirements. The NEC is typically updated every 3 years, so it is advisable to obtain the latest edition of the code and to review it carefully. In summary, NEC 312.8 provides specific requirements for the use of enclosures as junction boxes or raceways. Compliance with these requirements is essential for ensuring the safety and reliability of electrical systems. By carefully calculating the available wiring space and avoiding overcrowding, you can help to prevent overheating, electrical shock, and other hazards. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. Remember to consider the total cross-sectional area of the enclosure, the maximum wiring space allowance based on the 40% and 75% fill requirements, and the space occupied by existing components. Deduct the space occupied by existing components from the maximum wiring space allowance to determine the available wiring space for new conductors, splices, and taps. Ensure that the total cross-sectional area of all conductors, splices, and taps does not exceed this available wiring space.